To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. So I'm going to continue with the domestic electric circuit. In the previous two chapters, we discussed the different components of a domestic electric circuit. So you all can remember students, from the national grid, then the current power supply, electricity supply is given to the distribution subunits, and from there it comes to the step down transformer, and from the step down transformer 230 volt current, 230 volt voltage or potential difference current, that is alternating current with a frequency of 50 Hertz, and the maximum current that can enter into the domestic circuit is 40 amperes. So the first component in the household electric circuit after the supply cables, that is the overload circuit breaker. It allows the current of maximum 40 amperes to enter into the circuit. Then after that we have the electricity meter, which has a record of which records the amount of electric energy consumed by the household. Those two components, the overload circuit breaker and the electricity meter, both belong to the service provider. Then we have the isolator, the main switch with the main fuse. Starting from the isolator, all the components belong to the consumer. So we have the isolator, then we have the RCCB, that is the trip switch, and thereafter we have the distribution box containing the miniature circuit breakers. But in the modern household circuits, we have the isolator, trip switch and the MCBs of the distribution box all together in a consumer unit. So from there, power is supplied, electricity is supplied to the different components by conducting wires. And that happens through the MCBs, miniature circuit breakers of the distribution box. And there are two types of circuits, the lightning circuit or the lamp circuit, where you connect the light bulbs or plug sockets with maximum current of 6 amperes. So the maximum current that can flow into the lamp circuit or the lighting circuit is 6 amperes. Then we have the plug circuit, where you plug in the different electric appliances that use a higher current of about 12 to 13 amperes. So there the maximum current is 13 amperes. So two types of circuits. Then we saw the different types of switches, the plug sockets and the plugs, the 2-pin, 3-pin, square pin, round pin, all those we saw. So you are familiar with all those components. Now we will see how these components are connected as a circuit. So you all know students, like we discussed just now, there are two circuits. One is the plug circuit, where you connect all the electrical appliances, and the other circuit is the lamp circuit or the lighting circuit. And you all know, normally for a plug circuit, the current that can be drawn, the maximum current is 13 amperes, and for light bulbs, it is 6 amperes. So accordingly, there are fuses or MCBs connected in the distribution box. And also you are familiar with that all these components are connected parallelly in a household circuit, so that you can operate them individually. So that is what we are going to discuss now. So domestic electric circuit, each bulb and each plug in a domestic circuit is connected in parallel to one another. So that is very important. They are all connected in parallel to one another. So here you can see they are all connected in parallel to one another. Now what is the advantage of having them parallelly? Both bulbs and plugs. Now all of them have switches. So if they are parallel to each other, you can operate them individually. Now say in your room, you have a light bulb, you have a fan, or you have a light bulb and a charger plug socket. So if you want to switch on the light, you can only switch it on. There will be no current flowing to the plug socket. At the same time, when the light is switched off, you can use the plug socket, or you can use both. So you can use each of the appliance or each of the light bulb individually by turning on and off the switch. So that is one advantage of having them connected in a parallel manner. And also you're familiar with the concept of potential difference, how potential difference is same when the connection is parallel. So that is also something you need to remember. So always the bulbs and the plugs are connected parallel to one another in a domestic electric circuit. Then all switches should be connected to live wire. That is also very important. All switches should be connected to live wire. Now why is that? Always current flows into the electric appliance or the light bulb through the live wire, and it flows out when you have the complete circuit. The direction of the current, it flows in through the live wire, comes out through the neutral wire. So if you have the switch connected to the live wire, then you can control the flow of current into the device or the light bulb. So that is very useful. The reason is this. Now say if you want to change a bulb, if there is a burnt bulb, you want to change it, then you can switch off that particular bulb, the light connection, and then you can change the bulb. You will not get electrocuted. That is possible because the switch is connected to the live wire. So as you switch the light off, or you switch the off, switch is in the off position, then there will be no current flowing into the light bulb or the electrical appliance. So that is why all switches should be connected to the live wire. So it actually protects us from getting electrocuted if you are going to change a bulb or something. So that is something you have to remember, students. So therefore, touching a bulb circuit when the switch is in the off position does not cause electric shocks. So that is again important. So you can touch a light bulb when the switch is in the off position does not cause electric shocks because the switch is connected to the live wire. So you have to remember that. Then plug circuits are connected using cables that can withstand a current of 13 amperes. Now plug circuits, 13 amperes. Like I told you all students, if you remember, the light circuits are maximum 6 amperes. And to a light circuit, you all know you can connect 2 plug sockets but with a maximum current of 6 amperes. So light circuits or lamp circuits, they draw a maximum current of 6 amperes, whereas the plug circuits, they draw a maximum current of 13 amperes. And accordingly, there should be MCBs connected. So plug circuits are connected using cables that can withstand a current of 13 amperes. Why are these cables important? The cables, you all can remember, students? Now, all the cables or the conducting wires, they have a resistance. And always, or most of the time, you all know, some part of the electricity, the current, is used against resistance and it becomes heat energy. So, if there is current more than the maximum limit drawn from that cable, if current more than the limit that the cable can withstand flows through the cable can become overheated and that can lead to fire accidents. So, to prevent that, you have to use cables that can withstand a current of 13 amperes. That is for the plug circuit. So, you have to remember that also. Then, you can see only plugs are connected in these circuits and this type of circuits are often used in kitchens. So, here, why only plugs? Only plugs are connected in these circuits. Now, this is also something I have mentioned to you. Now in a lighting circuit or a lamp circuit, you have light bulbs and you can have two plug sockets that draw a maximum current of 6 amperes. There the current limit is less. But here, the current limit, the maximum limit is 13 amperes. So what will happen if you connect a light bulb? Light bulb draws a current of only 6 amperes. Here the maximum current is 13 amperes. So the MCB corresponding to the plug circuit will allow a current of 13 amperes. So even if there is about 10 amperes flowing through the light bulb, the MCB will not disconnect the power supply. So what can happen to the light bulb? It can burn off or it can be damaged due to overheating. So that problem will not be prevented. Overheating will not be prevented because the lamp circuit or the light bulbs, they draw 6 ampere, that is a less current compared to 13 amperes for the plug socket. So that is why you have to only connect plug sockets to a plug circuit. You have to remember that. Then, sometimes plug circuits are connected as ring circuits. So that is what is shown here. So sometimes they connect plug circuits as ring circuits. Now here, if you look at this diagram, the name given is a loop circuit. Loop circuit, ring circuit, both are same. They refer to the same circuit. So a loop circuit or a ring circuit. Now look at this diagram. If you can see, there is the live wire, neutral wire, earth wire. You can identify the colors. Live wire brown color, neutral wire blue color and the earth wire green color. And these points, these correspond to the different sockets. Now here you can see the 3 pins. Earth wire large pin, whereas the neutral and live wires the small pin. So those are 3 pin plugs. Now in this you can see it is a complete and continuous circuit, like a ring or a loop that is continuous. That is why we call it as a loop circuit or a ring circuit. It is continuous. And here you can see the live wire is one loop. Then you have the neutral wire as another loop and the earth wire as the other loop. And from the loops, the different sockets draw current. And they can be individually controlled by the corresponding switch that is connected to the live wire. So that is one way of connecting the plug sockets, a loop circuit or a ring circuit. And if we use this, what we can do is we can use cables with smaller diameters, because in a ring circuit that is an advantage. You can use conducting wires that are smaller in diameter. Normally you all know for a plug circuit, because the maximum current is 13 amperes, we need to use a conducting wire with a higher diameter. But if we have a loop circuit like that, you can use conducting wires with smaller diameters. So that is also something you need to remember. So sometimes plug circuits are connected as ring circuits, and such a ring circuit is shown in figure. So that is what I explained to you. You can see that here. So here you can see cables with smaller diameters can be used in such circuits since each plug receives current through 2 wires. So that is something you have to remember. So here you can see cables with smaller diameters can be used in such circuits since each plug receives current through 2 wires. Here, like I said, all 3 are connected as a loop. Now, you all know the function of the earth wire. If there is an electricity leakage, then the leaked current is earth, and also there is current flowing through the RCCB, so that the RCCB or the trip switch will cut off the power supply to the household circuit, the full circuit. But at the same time, you can see here both the live wire, neutral wire, both are connected in a loop-like manner or a continuous ring-like manner. You don't have one flowing in and one flowing out. Both are connected. So because of that, the power supply is done by two wires. Here you can see it is done by two wires. So because of that, you can use wires with less diameter. So that is an advantage of connecting the sockets as a loop circuit or a ring circuit. Is that clear, student? So these are things related to the domestic circuit, how the components are connected. You have to remember all these points. So if we quickly go back and have a look at it again. So you have to remember the bulbs and plugs all are connected in a parallel manner. And also all the switches are connected to the live wire. Then here, so that means if the switch is off, even if you touch the wire, you will not get electrocuted. So you can change the bulb by switching off after switching off the light, you can change the bulb if needed. Then here you can see plug sockets are always connected to wires that can withstand a current of 13 amperes. And also only plug should be connected to the plug circuit, and plug circuits can be sometimes connected as either ring circuits or loop circuit. That gives an advantage because you can use thin wires with less diameter, because current is supplied through two wires because of this loop-like connection. And all the sockets are individual. Individually, you can turn them on and turn them off. That is there for all light bulbs and plugs as well, because they are anyway connected parallelly. But in addition to that, here also you have that advantage. So that is something you have to remember about the domestic electric circuit or the household electric circuit, or what we can call as home electric circuit. Like I told you all the terms refer to the same circuit. So with that, students, I have completed the domestic electric circuit, the components and how they are connected and their functions. And in the next slide, we will look at some measures that are needed for protection. Some protective measures against accidents related to electricity or the household electric circuit. Protective measures in domestic circuits. Now we have discussed some of the protective measures. Now if you remember, if you recall all the components, overload circuit breaker cuts off electricity supply if there is a current more than 40 amperes. Then the main switch with main fuse and RCCB, main switch with main fuse allows only 30 ampere current. Same goes for RCCB, 30 ampere current. At the same time, the RCCB or the trip switch protects the household residents from electric shocks, but it does not provide any protection against lightning. You have to remember that. Then there are the MCBs. MCBs also provide protection. If the MCB is connected to a lamp circuit, more than 6 ampere current flows through them, then the circuit is cut off. And if the MCB is connected or it is for the plug circuit, then it allows a maximum of 13 amperes. So there are different types of protective measures, but the two main components that provide protective measures to the household are the RCCB, the residual current circuit breaker or the trip switch, and the MCB, miniature current circuit breaker. So those are the two main components. Now, protective measures in domestic circuits. Basically, there are two protective measures in domestic electric circuits, and these are the RCCB and the MCB. So if I write them down, residual current circuit breaker, that is RCCB or trip switch. Then we have miniature circuit breaker. That is the MCB. These are also fuses. Those are fuses. So those are the two components. Residual current circuit breaker or the RCCB or trip switch. Then miniature circuit breaker or the MCBs that are present in the distribution box. It can be either MCB or fuses. Here we can also use that, or fuses. Right. So if we discuss the two components one by one. First one, residual current circuit breaker, RCCB or trip switch. You know the function of a trip switch. What happens? There is a wire that is a live cable. The other wire is an earth cable. And what happens? There is the earth wire connected to the outer metal casing of an electrical appliance. And that is connected to the trip switch. And also there is a connection to the earth. So what happens if there is an electricity leakage? Immediately due to electromagnetic induction, a current flows through the trip switch, and because of that high current, the trip switch immediately cuts off the electricity supply to the household. So the residents or the consumer is protected from electric shock. And also, if there is a current more than 30 amperes flowing into the household circuit, then also the trip switch will disconnect the power supply to the household. So then also the electrical appliances are safe from high current. So that is how the residual current circuit breaker or the RCCB, the trip switch, provides protection to the household circuit. But you have to remember, it might turn off or cut off the electricity supply during lightning, but it does not ensure the protection against lightning. You have to remember that. So, in case of a current leakage in the electric appliances or an electric shock, the RCCB disconnects the power supply to the whole household. So, that is something you have to remember what I told you all now. Current leakage in the electric appliances or an electric shock, the power supply is disconnected to the whole household, not a part of the household, the whole household. The trip switch just switches off. The lever moves down. In addition to this, the RCCB also disconnects power if a current greater than 30 ampere flows through the circuit. So, disconnects power if a current greater than 30 amperes flows through the circuit. So, this prevents fire arising from overheated main cable. So, that's important. So, this actually prevents fire arising from overheated main cables. We have discussed that. The cables have resistance, and if there is high current flowing through it, the cable can become overheated. And you all know we use a cable with a specific diameter. So, if that heat is too much, that particular conducting wire can melt, and that can lead to a fire. So, that can be prevented by using a residual current circuit breaker or a tripped switch. So, it protects the resident or the consumer from electric shocks, and also it cuts off the power supply to the household itself, the whole household, and also if there is a high current protector, circuit breaker. We can say high current circuit breaker, because if the current is more than 30 amperes, it cuts off the power supply to the household. So, that is how the trip switch protects the household electric circuit and the residents. You have to remember that. So, with that, students, I am going to move on to the next slide. Fuses or MCBs, the second type of protection. So, you are familiar with this as well. Now, the fuses or MCBs are present inside the distribution box. You know that. So the household is divided into different areas, and there is the lamp circuit or the lighting circuit as well as the plug circuit. And there are different fuses for different areas as well as the lamp circuit and the plug circuit, because the maximum current that can flow through the lamp circuit or the lighting circuit is 6 amperes, and the maximum current that can flow through the plug circuit is 13 amperes. So based on that, protection is provided. And you all know, in the modern household, the miniature circuit breakers that are present inside the distribution box are contained in a consumer unit along with the trip switch and the isolator. So that is something you already know. Fuses or MCBs. These electrical components prevent large currents flowing through domestic circuits. So that's again something you need to remember. These electrical components prevent large currents flowing through the domestic circuits. Fuses or MCBs do not provide protection from accidents due to current leaks or electric shocks. That is done by the trip switch or the RCCB. Very important. So here you have to remember, students, this is something you have to keep in mind, right? Fuses or MCBs do not protect from accidents due to current leaks or electric shocks. That's important. If there is a power disconnection due to any of the above reasons, the overload circuit breaker should be open, turned off. You have to off the overload circuit breaker. Next, the lever of the RCCB or that of the MCB should be turned upwards to the on position, and then close, that means turn on the overload circuit breaker again. So let's say if the trip switch or the MCB switches off the power, cuts off the power supply, then what you need to do is you need to first turn off the overload circuit breaker. Then you turn on the MCB or the trip switch, and then only you again turn on the overload circuit breaker. And if that happens again, if again the trip switch cuts off the power or the MCB cuts off the power, then of course you shouldn't switch it on again, or you should make sure that you remove the device from the connection if it is an electric appliance. Let's say, for example, when you are using an electric iron to a certain plug point, the trip switch falls or the MCB disconnects the power supply. Then of course you have to remove that device. You need to switch off that plug socket, and then maybe you can use the household circuit. But otherwise, if you are not sure what appliance is causing this particular problem, then of course you should get a technician to take care of the problem, to look at the problem and to rectify the problem. That is something you need to keep in mind. So here you can see, if the power supply gets disconnected again, the circuit should be repaired by an electrician. You should not try to repair it. You should not try to use it over and over again if the problem persists. If again and again, if the trip switch falls or the MCB cuts off the electricity, you shouldn't continue using the electricity. You have to be careful. So that is how we get protection. The RCCB, residual current circuit breaker, or the trip switch, protects from electric shock, electric leakage, and also high current more than 30 amperes. The MCBs, miniature circuit breakers, they don't protect the household recipients or the consumer from electric shock or leakage, but they protect the electric appliance from excess current and the accidents that can be caused by high current. That is more than 6 amperes for the lamp circuit and more than 13 amperes for the plug circuit. So that is what you need to remember, students. So these are the components that provide protection. In the next slide, I will be discussing some measures that you can use as protection. So then, precautionary measures for safety. Now, in addition to the protection provided by the trip switch or the RCCB and the MCB, we also need to take certain precautionary measures. I'm sure you're familiar with most of them. First thing you all should know, you should not touch any of the switches, plug sockets with wet hands. And if you're doing some repair, that is if you want to change a bulb that is not working, then you have to make sure you're wearing either rubber slippers or you're standing on a rubber mat. So like that, you have to take precautions, or you can even wear rubber gloves so that you will not get electrocuted. Even when ironing clothes, it's better if you can either stand on a rubber mat or you wear rubber slippers. So those are things. And you should not touch any of the electrical appliances with your wet hand. So all those are different precautionary measures that you already know. There are a lot more that we will discuss now. I think even those are familiar to you. So then, here the first one. Only fuses appropriate for 6 ampere and 13 ampere currents should be used. So that is the first one. Now when you have the fuses, you have to use the appropriate fuses. Earlier also we discussed that the lighting switches, the bulbs should not be connected to a plug circuit. Why? For the bulb, it is only 6 ampere current, but for the plug circuit, it is 13 ampere current. So, if you connect a bulb to a plug circuit, even if there is more current, the fuse will not cut off the electricity. So, because of that, the bulb can burn off. It can get damaged. So, because of that, you have to be careful. The same goes for the other way also. You should not connect any of the plug sockets to the lamp circuit. So, you have to be careful. The appropriate fuses should be used. Many electric appliances that draw a total current exceeding the capacity of the plug socket should not be connected to the plug socket through a multi-plug. The next one. Now, there are multi-plugs available. You are familiar with that. One plug top with many different types of holes. Now, say there will be a 2-pin plug, 2-pin square plug, 2-pin round plug. Then there can be 3-pin plugs, again different sizes, different types. So that is there for the purpose of connecting different types of plugs to the socket. Let's say on the wall you only have a round pin plug socket. But if you want to insert a square pin plug to that, you can use that multi-plug. But at a time, it is not good to connect many devices simultaneously. Say if you have 3 different devices plugged in from the top, from the side and from the front, if you put in many devices, then what will happen? If all the devices need to draw up about 13 ampere current, all of them together, they will be drawing about 40 amperes of current. 13 into 3. That is a very large current. So that is not good. There can be overheating of the electricity cable and that can lead to a fire. So that has to be prevented. You should not do that. Then the next one. Only plugs suitable for a plug socket should be inserted into a plug socket. Wires should not be inserted into a plug socket. Now sometimes we tend to do this, no? You have a 3-pin plug socket, but you have a 2-pin plug. What we do is, we put a pencil or a pen or a tester into the earth pin and then you plug in the 2-pin plug. That is not correct. And especially inserting a pencil. I am sure some of you all might have done that before. It is not good at all. Why is that? Now the pencil has the lead that is graphite. Graphite is a very good conductor of electricity. So it is not advisable to use a pencil to push the earth pin and then to plug in the 2-pin plug. So that should not be done. And you have to make sure small kids, small babies, small kids, they try to insert things into all these plug sockets. So they might put a pencil, they might even put a spoon or a fork, something that can really conduct electricity into these plug sockets. So you should be an example. You should make sure that you put the correct plug. Only plugs suitable for a plug socket should be inserted into the socket. And also, now sometimes when people do this household construction work, repair work, what they do is they put wires into the plug socket. That also should not be done. Only the plug top has to be plugged in. The plug has to be put into the socket, not the wires. That has to be avoided. Then when using an electric iron for ironing clothes, rubber slippers or a rubber carpet underneath the feet should be used. So that is something I told you all. So that while ironing, sometimes we use steam iron. So there is water. You pour water into the iron, you use the steam iron, and there it is better to make sure that you are standing on a rubber mat or you are wearing rubber slippers so that you will not get electrocuted. It is good to use a mat in front of a refrigerator for safety. That is also good. Why? Inside the fridge, inside the refrigerator, you keep food items or juices, liquid items. So if the liquid spills and if you stand on it and by chance if there is an electricity leakage, then of course there is a high tendency that you will get electrocuted. So if you have a mat in front, you will be standing on that insulator mat. So even if there is an electricity leakage, you will not be harmed. So it is always good to do that. Then tasks such as changing burnt bulbs in bathrooms should not be done without turning off the overload circuit breaker or the main switch. Overload circuit breaker is usually outside the house with the electricity meter, but the main switch is inside the house. So it's always better to turn off the main switch. That is the isolator, main switch with the main fuse. So you have to turn off the isolator or the main switch and then do the tasks like changing burnt bulbs. That is also important. Then the next one, when electric appliances are not in use, their plugs should be disconnected from the socket. So this is also something we tend to neglect. We always plug in the devices, we just let them be so that it's convenient for us. But it is a good practice to remove the plugs, disconnect the plug, switch them off, remove the plug, disconnect them when you are not using the electrical appliance. So another precautionary safety measure. I'm sure you all can understand all these students. So with that, I'll move on to the next slide where we discuss some more of these measures. Here also you can see, if there are strong lightning strikes, radio receivers and television sets should be unplugged as much as possible. Now, why mainly the radio and television? Because they have ways of receiving signals. They usually have antennas or signal receivers. So, it is easier, and sometimes you even connect them to different types of cables. So, there it is easy for the lightning to be conducted, the charges, electric charges to be conducted through those wires and the receivers. So because of that, the devices can be damaged and it can cause harm to the household resident as well. So it is always advisable, if there is strong lightning, radio receivers and television sets should be unplugged as much as possible. In such cases, it is advisable to refrain from using any unessential electric devices. Say like talking anyway, normally talking on the mobile phone while it is plugged in is not correct or it's not good. And especially if it is raining and if there is thunder and lightning, you have to refrain from doing that. And even the other devices, if you can avoid, do not have the iron plugged in or do not iron clothes when there is lightning. Try to even turn off and remove the plug of the refrigerator. So like that, try to remove electrical appliances as much as possible. And remember, RCCB do not protect the domestic circuit from thunder. So this we have discussed before also. They can sometimes cut off electricity, but that is not their function. RCB does not protect the domestic electric circuit from lightning or thunder. So you have to remember that. Then electric devices should not be used when the body is wet. So this is also something that I told you all. Now say sometimes some of the bathrooms where once you have a wash, once you have a bath, when you come out, you have the dryer connected inside the bathroom itself. So either you have a separate room or separate space, or it is in the same area. But wherever it is, you have to make sure. Or else even if you have a bath, you come out, and if the hair dryer is connected in your room, still you have to make sure that your body is completely dry before you touch the dryer. Your hands are completely dry, and you are wearing your legs, hands, everything is dry, only your hair is wet, and you are wearing rubber slippers, you are all well protected, then use the hair dryer. So you have to be careful. Those are instances where you have the chance of getting electrocuted. So electric devices should not be used when the body is wet. Electric switches must not be turned on or off with wet hands. Again, a similar thing. During a power failure, switches of electric appliances should not be turned on. So before you rectify the problem, you should not turn on the appliances. You have to keep them switched off, or you can even remove the plugs from the socket, and then you correct the problem, and then you plug them in. You test, and after that, if everything is rectified, you again plug in the electric appliances. That is another thing. The next one, in case of a fire, the domestic power supply should be disconnected using the overload circuit breaker. So that's also important. In case of a fire, you use the overload circuit breaker to disconnect the power supply so that the completely power supply is cut off. Because the normal fire, it can lead to a fire in the electricity circuit that can cause more damage. And that type of fire is difficult to control also. So because of that, in case of a fire, you make sure that you immediately turn off the overload circuit breaker so that the power supply to the household is completely cut off. Then, all maintenance work and installing power extension should be done by a trained electrician. So you don't just go and connect a wire or install something related to the power extension. That has to be done by a trained electrician. You can just change the bulb. A burnt bulb can be changed. That's not a problem. But fixing a new plug socket or connecting another additional wire, those have to be done by a trained electrician. And the last one, the functioning of the RCCB should be checked every few days by pressing the test button. So you're familiar with the test button. I showed you all how that works. When you press the test button, automatically the trip switch falls off. So it cuts off the power supply. So that has to be tested every few days. At least once a month you have to test it. If not every few days, at least once a month you have to test it. But it is good if you can check it every few days. So those are different protective precautionary measures that you need to take when using the electricity and electrical appliances so that you are safe from many accidents. So with that, students, I have completed this topic, but I'll be moving on to another topic where we discuss how we can calculate the amount of electric energy that is consumed by the consumer. So with that, I will move on to the next slide. So measuring electric energy in kilowatt hours. So this is something that you already know, students, the electricity meter. Now there are a number of units that are used by the consumer. So each unit is equal to 1 kilowatt hour. That is how the electric energy that is used by the consumer is monitored. So, if we look at the commercial unit of measuring electric energy. So, commercially we consume electricity from the electricity provider, who is the service provider. So, there the commercial unit is kilowatt hours. Electric energy is measured in kilowatt hours. That is something you have to remember. By the domestic electricity meter, electric meter or the electricity meter. And 1 kilowatt hour is the amount of electric energy consumed during 1 hour by an electric appliance with a power consumption of 1 kilowatt hour. If we try to understand that, so if we have an appliance that has a power consumption of 1 kilowatt. What is that equal to? That is 1000 watts is equal to 1 kilowatt. So, if you use this appliance for 1 hour, then the energy consumed is equal to power into time. So, there if the power is 1 kilowatt and the time is 1 hour, then the energy consumed is 1 kilowatt hour. That is the electric energy consumed. Although energy is usually measured in joules. Now, this is something you all already know. Work, energy, all those are measured in joules. So, even the electric energy is measured in joules. When the consumption is high, energy in joules gives a large numerical value. Because of this, kilowatt hours is used as the measuring unit of electricity. The energy consumed in a second by a device with 1 watt power is equal to 1 second or 1 joule. That is also something you have to remember, students. The energy consumed in a second by a device with 1 watt power to 1 watt second or 1 joules. It is equal to 1 watt second or 1 joule. Now, we will try to understand that. Now, here, first we said the kilowatt hour is used as the commercial unit. Why? Because if the amount of electric energy consumed is a large amount, then you will get a very large value if you measure it in joules. We will try to understand that. We will try to calculate and see how much of energy is in joules that is equal to 1 kilowatt hour. So, you have 1 kilowatt hour. That is equal to what? 1 kilowatt into 1 hour. That is what I showed you all here. So, when you say 1 kilowatt, that is equal to 1000 watts. Now, to get energy, we need to have the time in seconds. Joules per second is power. So, energy, joules. So, if you have power into time in seconds will give you all the energy. So, 1 hour is equal to how many seconds? 1 hour has 60 minutes. So, you multiply by 60. And each minute has 60 seconds. So, you need to multiply by another 60. So, 1000 watts equals 1 kilowatt. So, 1000 watts into, instead of 1 hour, we have 1 into 60 seconds. That is how we convert. So, here, if you multiply all those, 6 into 6, 36. And there are 3, 4, 5 zeros. So, 36,000 you need to have 5 zeros. Like I said, 6 into 6, 36. And there are 5 zeros. So, this is how we consume energy. Now this is equal to watt second. Watt second is what? Watts is power, second is time. So that is equal to energy in joules. 3 joules of energy. So if you look at the equivalent value, 1 kilowatt hour is equal to 3,600,000 joules. So that is a very large value. Or you can say 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. Can you all see that now? This is a very large value. So this is why we use kilowatt hour as one commercial unit. 1 kilowatt hour, 1 unit. Otherwise, you have to take it like this. Or it is going to be 3,600,000 joules. So that is a very large amount. It's difficult to use the joules as the commercial unit. So because of that, we use 1 kilowatt hour. But you need to know the equivalent value. Is that clear? So this is what is given to you all here, students. Now here see, usually measured in joules, although energy is usually measured in joules, when the consumption is high, energy in joules gives a large numerical value. Because of this, kilowatt hours is used as the measuring unit of electricity. We have understood that. The energy consumed in a second by a device with 1 watt power is equal to watt second or 1 joule. That is another part that we have already discussed, but just again to recall. Recall what we learned before. Now you can remember power P equals VI. This is one equation. Then we had energy equals power into time. So based on this, we got the equation energy equals VIT. So these are all equations that we used before. So what does it say? If you use 1 watt for 1 second, the energy that has been used is equal to 1 joule. So here, energy equals power into time. If there is an electric appliance with the power of 1 watt, if you use it only for 1 second, so you get the value as 1 watt second, and that is equal to 1 joule of energy. Is that clear? So this is the last statement that we saw there. So here, energy 1 joule is going to be equal to 1 watt second. So those are the things you need to remember, students. 1 joule is equal to 1 watt second. That is energy. And also here, 1 kilowatt hour is equal to 3,600,000 joules, or 3.6 into 10 to the power of 6 joules. And the commercial unit of measuring electricity is 1 kilowatt hour. Is that clear? So with that understanding, I will move on to the next slide where we will do a calculation to calculate the commercial unit or number of units of electricity consumed at a certain instant. When the power of domestic electric appliances and the number of hours they are used are known, the amount of electricity consumed by these devices can be easily calculated. Say for example, when the power of a domestic electric appliance, let's say a bulb, say a bulb of power, we will say 60 watts is used for 4 hours per day. 4 hours per day. If you are to calculate the electric energy consumed by this particular bulb in 1 day. So, energy consumed by the bulb in 1 day, that is equal to power into time. Now we have the power 60 watts. 60 watts into time 4 hours. So what is this? This is 60 watts into 4 hours. So 240 watt hour of energy has been consumed. If you want to convert it to the commercial unit, this should be in kilowatt hours. So then we will need to divide it by 1000. So here, number of units of electricity consumed should be equal to 240 watt hours divided by 1000. So that will be equal to 0.24 kilowatt hours. So 0.24 units. That is the amount of electric energy consumed. So 0.24 units will be recorded in the electricity meter. Now this is just one bulb for 1 day. Like this, in a household, there will be many light bulbs, many other electric appliances, and also we will be using them for different time periods as well as for different number of days in a month. And usually the electricity is billed for a month. So there we need to know how to calculate the electricity consumption for a month. I will do that in the next slide. So before I do that, I will just go through the calculation quickly once more. So here we have a bulb that has a power of 60 watts and it is used for 4 hours per day. And the energy consumed by the bulb in 1 day is given by power into time. Here, of course, we are considering the time in hours because we measure the commercial unit is kilowatt hours, not joules. So 60 watts into 4 hours, that is 240 watt hours. But it has to be in kilowatt hours if you want to calculate the units. So because of that, you need to divide it by 1000 here. You can also incorporate the step there. You can directly write it as 60 watts into 4 hours divided by 1000. Then directly you will get this final answer 0.24 kilowatt hours. Is that clear, student? So then I'll move on to the next slide. If 4 bulbs each having a power of 100 watts. So here 4 bulbs 100 watts are used for 3 hours. And then there are 5 bulbs with a power of 60 watts each are used for 4 hours daily. Find the electricity consumption during a month. Now this daily, and when we say month, we consider it as 30 days. We need to calculate it for 30 days. So then, you need to calculate the power consumed by the 4 bulbs, then the 5 bulbs. Again, you can do them separately and add them together, and then you can multiply for a month. So here, if we calculate the energy consumption for the 4 100 watt bulbs. What do we need to do? We need to multiply the power by the number of hours and the number of bulbs. So here power is 100 watts. The number of hours it is used is 3 hours per day. And there are 4 such bulbs. One bulb 100 watt, 3 hours per day. Like that there are 4 bulbs. So we need to multiply that by 4. So you will get the answer as 3 into 4, 12, 12 into 100, 1200 watt hours. Then we have, you can check here, 5 bulbs, 60 watts and 4 hours per day. 5 60 watt bulbs. So 60 watt power, and each bulb, just to confirm, is used for 4 hours per day. 4 hours per day, and there are 5 such bulbs. So one bulb 60 watt and is used for 4 hours. That is the energy consumption. Like that there are 5 bulbs. So into 5. So that is going to be equal to 4 into 5, 20, 20 into 60, again 1200 watt hours. So all the bulbs together. So all the bulbs per day is how much? 1200 plus 1200 watt hours. So this is for one day. If we get the final answer, 1200 plus 1200, 2400 watt hours. So like this, they'll be using the bulbs for 30 days. So 30 days. 2400 into 30 watt hours. And to calculate the number of units. Number of units. Now here this is going to be in watt hours, but we need to have the unit in kilowatt hours. So what do? We need to divide it by 1000. So 2400 into 30 divided by 1000 will give you kilowatt hours. So that is going to be the commercial unit. So you can cancel off the zeros. 24 into 3, that is going to be 72 kilowatt hours. So the household will use 72 kilowatt hours of electric energy, or in other words, 72 units of electric energy, because 1 kilowatt hour is equal to 1 unit. So they will consume 72 units of electric energy. That is how we calculate. For a household circuit, when you are given different types of electric appliances, different types of bulbs, you will know the power of each device. Then you know the number of hours it is used per day. Like that, sometimes they will tell you for how many days it is used. Then you have to calculate for a month. Normally a month we consider it as a 30-day month. Is that clear to you? So that is how we calculate the electric energy consumed. I will quickly go through the calculation again. So in the question, they have given you information: 4 bulbs, 100 watts each, used for 3 hours a day. 5 bulbs, 60 watt power each, used for 4 hours daily. And the month is considered as 30 days. So if you calculate the energy consumption for 100 watt bulbs, 100 into 3 hours into 4, so that's 1200. Then 5 bulbs 60 watts each and for 5 hours per day. So 60 into 4 hours into 5, that is also 1200 watt hours. Then all the bulbs per day, you get 2400 watt hours. For 30 days, you need to multiply that by 30. And if you want to calculate the number of units, watt hours has to be converted to kilowatt hours. To do that, you need to divide by 1000. So you get the answer as 72 kilowatt hours. So 72 kilowatt hours is equal to 72 units. 72 kilowatt hours is equal to 72 commercial units. That is how electricity is billed for the consumer. I am sure you all can understand that. So with that, I am going to move on to the next slide. So here we have the summary. That means I have completed the lesson. So let's look at the summary. Summary: the power of an electric appliance is the amount of electric energy consumed by it in a unit time. So that is why we use the equation: when a current I passes through an electric device due to a potential difference V, its power P is given by P equals VI, voltage into current. And electric energy E consumed by an electric device over a time period, T is given by E equals VIT. So those are the equations you all need to remember. P equals VI, E equals VIT. And domestic electricity meter measures electric energy in kilowatt hours. That is what we calculated in the previous example. 1 kilowatt hour is the energy consumed during 1 hour by an electric device that has a power of 1 kilowatt. So here 1 kilowatt hour is equal to 3,600,000 joules. That is also something that we already calculated. Then in addition to that, in the lesson we discussed the different components that are present in the household electric circuit. You all know what they are, you know their function and how they protect or how they provide different functions to the household consumers. So that is the end of this lesson, students. We have discussed the domestic electric circuits and their components and power, energy and the commercial unit of electric energy. So I am going to end this chapter, and in the next chapter I will discuss the questions given in your textbook.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.